we're going to take a look at another triangle congruency theorem, but this one is specifically for right triangles. So this is known as the hypotenuse leg theorem. So if both triangles are right triangles and the hypotenuse and one set of legs are congruent, then we can say that the two triangles are congruent. So essentially what we need in order to prove these triangles are congruent is we need two right triangles. The hypotenuse needs to be congruent to the hypotenuse, and a leg needs to be congruent to a leg. So let's take a look at a few. So if we're looking at these triangles, we want to determine if they are congruent or not by the hypotenuse leg theorem, or another theorem that we could use as well. So in this case, we do have two right triangles, so that's satisfied. We have a set of legs that are congruent, and we have a set of hypotenuses that are congruent. So you want to remember that this is the side-side angle. This does not work in anything other than a right triangle. So this is our hypotenuse leg theorem that says that yes, these two triangles are congruent. So here again, we have in number two right triangles, so we can add this over here. So they have the right triangles, right? They have the hypotenuse, and then the leg that's congruent is the shared side in the middle there. Remember, we use our reflexive property for that one. So this one also works via the hypotenuse leg theorem to prove that those triangles are congruent. Now this is an example where our hypotenuse leg doesn't work because we don't know anything about the hypotenuses here. But that doesn't mean we can't prove the triangles are congruent. All of our other triangle congruencies work. So we have a side, angle, side. So again, side, angle, side. And that is absolutely one of our theorem, or actually that was a postulate. So that was by our side angle side postulate. So we can still prove they're congruent even if it's not a hypotenuse leg. We just have to default to those triangle congruencies that work for all triangles. So now let's take a look at doing a proof that uses this theorem here. So I'm going to start this like any other proof where I'm actually going to work with my figure and try to decide where the proof needs to go first, and then we'll go ahead and actually write out the proof. So on this figure, I'm going to write what I know. So CE is perpendicular to XC. I can't really mark that on the figure, but I can infer something from that, which is that we have a right angle here. And let's see, CE is perpendicular to YE. Again, can't really mark that, but I can infer a right angle. So in blue, it's stuff that I have inferred, which means that it's stuff that I need to give a reason for in my proof. So D is the midpoint of CE. So again, that means that I can kind of infer here that we have two congruent sides there. And then XD equals YD. So remember, when we drop that notation, we mean measurements. If measurements are equal, then the figures are congruent there when we're talking about that. That's our definition of congruency. So now we have marks in blue of things that we inferred from the information given that we now need to write a proof with reasons as to why we were allowed to think those things. So let's get started on our proof. So we're going to have our statements, right? Things that we think we know, and reasons, telling our reader why do we know those things. So we're always going to start with our givens. So we're just going to work with our givens there, and we're trying to prove that these triangles are congruent. So I need essentially all of those tick marks. I need a reason for why they are true so that I can actually say that the triangles are congruent. So let's start working through that. So first thing I'm going to work with are the right angles. So I'm going to say here that angle C and angle E are right angles. Okay, they're right angles. And I know that because the definition of perpendicular, right? That's what perpendicular tells us. So let's keep going here because I not only need to say they're right, I need to say they're congruent. So I'm going to go in a third line. Angle C is congruent to angle E because right angles are congruent, right? They're both right angles, they're congruent. Okay, so what else do we need to know? Well, great, they have right angles. Well, that tells me that they're right triangles because hypotenuse leg theorem only works in right triangles. So we need to state, hey, these are right triangles. So triangle, let's go DCX, and remember to pay attention to your ordering, is congruent, oh, excuse me, is not, we're not going to do congruency yet. We're not there yet. And triangle, I should say, let's see, CPCTC, we're going D, then across the single side to the right angle. So DEY are right triangles. They're right triangles. And we're just going to say, well, that's because definition of right triangles, they have right angles, therefore they are right triangles. Okay, so let's keep going. So now we've kind of taken care of that our right angles are congruent. These are right triangles. Great. So let's work with our other markings on here. So we have some congruent sides that we need to prove. So CE is congruent to ED because that is the definition of a midpoint. We knew that because we had a midpoint there. And then lastly, we can say that XD is congruent to YD because that's the definition of congruency. Okay, definition of congruency. If two figures are congruent, their measurements are equal. So we were just using kind of the reverse of that. So now I have officially given a valid reason for each of those marks on the triangle, which means I'm ready to say that they are in fact congruent. So triangle C, no, we'll be consistent, DCX is congruent to triangle DEY because of the hypotenuse leg theorem. Okay, so all of our lines before were basically giving us justification for that hypotenuse leg theorem.